Hello, and welcome to the developer training session, where we'll learn how to customize Jira with Forge, Atlassian's cloud app development platform. I'm Neil, a developer advocate at Atlassian, which means that I advocate on behalf of all developers who build things on top of the Atlassian platform, including marketplace partners, solution partners, as well as customers who build custom apps for their own internal use. This session is targeted for Forge beginners. If you're more of an advanced Forge developer already, then please bear with me, as some of the topics I'll be covering you may already be familiar with. All right, let's kick things off. Here's the agenda of what we're going to cover today. I realize that we all learn new things in different ways and at different paces. Some people like to try and read and comprehend every concept before they ever write a single line of code, while others' learning style is more trial by fire and trial and error. And that's me. I like to learn by example, and that's what we'll be doing today, learning by building some Forge apps together. We're going to start with some introductory topics so we can get a better understanding of what the Forge platform is and some of its fundamental components. After covering some of those high-level concepts, we're going to roll up our sleeves, get hands-on by writing our very first Forge app together. As we progress, we're going to learn about different extensibility building blocks that we can use in our Forge app, capabilities like the product REST APIs, subscribing to product events, or ways to enhance Jira's UI. And by the end of the session, you're going to have a better understanding of how to extend Jira Cloud's functionality by building custom behaviors with the help of Forge. First, let's start by defining what Forge actually is. Forge is Atlassian's serverless development platform, designed specifically for extending Atlassian cloud products. It's quick to get started building an app, even for those of you that don't consider yourself a professional software developer. I sometimes refer to Forge as a low-code platform because it handles a lot of the heavy lifting for you. So why use Forge? Let's take a look at some of the benefits of building an app on Forge. Earlier, I described Forge as a serverless development platform, and part of what that means is that Forge apps run and store data in the Atlassian cloud alongside the products. So from the developer's perspective, by Forge apps running inside the Atlassian cloud, means that you don't need to go and spin up your own servers and databases. Atlassian handles all of the infrastructure management and data storage for your app. And that's a big deal. It can save you a lot of time, money, and heartache not having to manage infrastructure. From the onset, security was top of mind when it came to creating Forge. When you build apps with Forge, you're leveraging a platform that adheres to best practices in security. Atlassian provides robust security measures, including managed authentication, authorization, tenant isolation, and data management. Similar to the benefits I mentioned about being a hosted platform, having the Forge platform provide these security measures not only provides a better security posture that benefits our users and customers, but it also frees up more time and resources for developers like you to focus on innovation. And finally, Forge empowers you to create highly customized apps with robust features and polished user interfaces. This means that you can do all kinds of things like add sections or pages to Jira or display useful and critical information within different areas of the product. Forge gives you a couple different ways to build out UIs with pre-built components with something that we call UIKit, or if you prefer to have more freedom to design and control your own UI, Forge also affords you that ability with something called custom UI. We're going to be using UIKit components in our exercises today. So in a nutshell, by using Forge, you can focus more on building solutions and innovating, and worry less about things like managing infrastructure and scaling. Those were some of the high-level benefits from using the Forge platform. But what kind of apps can you build? While theoretically there are countless types of apps that you can build with Forge, I'm going to bucket them into three groups. You can build a Forge app that provides a bridge or pipeline to an external product or platform into the user's workflow within an Atlassian product. Common use cases for integrations include building connections between Jira Cloud and other enterprise software systems that your team uses. For example, some of the most popular Forge apps you'll find on the marketplace are integrations with external CI/CD tools. Next, there are Forge apps that are integrated directly into the product UI. As Jira users, you know there are many different screens and views for projects, boards, and issues. Forge provides the ability to smoothly and seamlessly integrate your app into many different screens and views within the product UI, including adding new sections and pages. There are also Forge apps that enhance Jira's existing behavior. You can build an app that adds custom validations to workflows. For example, if you want to enforce stricter work in progress limits on your Kanban boards, you can do that with Forge with just a few lines of JavaScript. So if you're a Jira administrator or work closely with one, Forge can give you ways to customize workflows with code. So you can build custom validators, conditions, and post functions. And by the way, a Forge app doesn't necessarily have to fall into a single bucket. You might want to build an app that does 2 or more of these things. On that note, here are a couple of other types of apps you can build. A common use case is building a Forge app that performs complex automation. An automation can perform actions after being triggered by a product event, like a value changing on an issue. Or an automation can be executed on a scheduled time interval. For example, you can build a Forge app that calls an external REST API whenever a new issue is created. When working with Jira, there are times when your team needs its own bespoke custom field, a field with functionality that's not part of the off-the-shelf offering. With Forge, you can build a field with your own defined behavior. Towards the end of the workshop, there's a use case we'll address in an exercise where we'll build a basic custom field that's been requested by a lot of customers through the years. Next, let's learn about a few fundamental parts of Forge. And once we have a basic understanding of these things, we're going to be in a great position to start building our first Forge app for Jira. The first fundamental part of Forge is the command line interface, or the CLI. It's a simple yet powerful tool that lets you easily and quickly create, deploy, and install Forge apps. Now, it does have many other useful features, but if there was one thing that you could take away from this slide, it's that building a Forge app always begins with the Forge CLI. The CLI works the same across PC, Mac, or Linux. You simply go to the command prompt, and that's where you'll use the Forge CLI. As we progress through the session, you'll get more familiar with the CLI commands. Another fundamental part of Forge is the manifest. Every Forge app needs one. The manifest can be thought of as the blueprint for your app. It outlines the different Forge modules, functions, and resources that your app will use to extend the product like Jira. It's just a text file, YAML format, which you might already be familiar with as it's often used in configuration files. So again, the manifest, just a YAML file that describes and maps the structure and functionality of your app. We're going to be getting hands-on with the manifest in the exercises where it's going to be a lot easier to understand what its purpose is. The last fundamental part of Forge we're going to cover right now are modules. If the manifest is a blueprint, you can think of modules as the building blocks. In Forge, we provide modules which will allow your app to extend and interact with Atlassian products. Modules give your app capabilities of doing things inside the product like Jira or Confluence. If you look at the manifest up here on the screen, the app is using the Jira Issue Panel module, which adds a new section to the issue view where the app will be displayed. Whatever module your app needs, you simply have to add it to the app's manifest file. And of course, a list of every available module is in the documentation at developer.atlassian.com. And there are modules that are common across all products, and we call them common modules in the documentation. These modules are product agnostic, and you'd use them whenever you're building a Forge app for Jira, Confluence, Bitbucket, or Compass. The most widely used common module is probably the function module. And the function module is vital to an app since it lets you define the app's behavior. For example, when we add an issue panel to our app, the function module describes how that issue panel behaves. Another common module is the trigger module, which can be used for automating tasks. You'd use this module when you want your app to subscribe to specific product events. Once the Forge app receives this event, the function defined in the module is invoked or to run. So, looking closely at this fragment inside of a manifest, the event that our app subscribed to is the Jira issue updated event. So, when an issue is updated, that triggers a function to be run within our Forge app. So, we've covered the high-level benefits of Forge and a few of the platform fundamentals like the CLI, the manifest, and modules. It's now time for us to apply some of the things we've just learned and start building our first Forge app for Jira. Are you ready? All right, let's open up our editors and terminals and write some code together. So to follow along this workshop, you'll need to get your development environment set up on your computer. Don't worry, it's not a lot of work, and it shouldn't take you very long. First, you'll need to install Node.js. Building Forge apps requires Node.js, which is a free open source JavaScript runtime environment. Once you have Node.js installed, you'll be installing the Forge CLI or command line interface. Again, the Forge CLI is the command line interface for building and deploying Forge apps. Next, you'll need your own free Jira Cloud instance for development and testing use. Even if you have admin access to your company's Jira instance, we highly recommend using a test site, like a development site dedicated just for this. And while not required, a code editor that is JavaScript aware is recommended. I'm going to be using Visual Studio Code during the workshop. It's a free editor that you can download and install yourself. If you visit the URL above, go.atlassian.com/forge-101, it'll take you to the Getting Started guide for Forge, which includes detailed instructions for installing Node.js, installing the Forge CLI, and more. If you don't have these things installed on your computer yet, just pause the video right now and take a few minutes to get everything set up. All right, assuming you've got your dev environment set up, let's build a Forge app together. So this training workshop is designed and catered for Forge beginners. So if you find that I'm going too fast, just pause the video. Depending on your internet connection speed, you might find that some of the commands or steps take a little bit longer or shorter to complete than what's happening on my screen. We should be able to build your first Hello World Forge app in less than 10 minutes. Before we call the first command, let's just make sure that you have a terminal open or command prompt. And once it's open, navigate to a directory or create a new directory where you want to create your first Forge project. And before I start live coding, I'm going to quickly discuss the first two steps to creating our first Forge app. The first step is the command line interface command, Forge create, and it's going to prompt us to type in the name of the new app that we're building. So after we type in Forge create, it's going to ask us to enter an app name. I'm just going to type in Hello Forge. Next, it's going to prompt us to select an app category, product, and a template to use. Here, we're going to select UIKit as the category. For the product, we'll choose Jira. And for the template, we're going to scroll down until we see the Jira issue panel and then hit enter. Okay, so right now I'm going to jump into my other screen where I'll perform these commands, and I invite you to do the same thing along with me. Here I have my terminal window. I'm using the terminal that's inside of Visual Studio Code, but you can have a separate terminal altogether. I created a empty directory, and this is where I'm going to create my first Forge app. So that first command was Forge create. The name for our app, we'll call it Hello World. And we're going to go down to UIKit, hit enter. Move down to Jira. I'm using my arrow keys, and we're looking for Jira issue panel, and hit enter again. And what it's doing now, it's creating the app locally on my machine by downloading a template of an app. It's registering the app, so now the app is registered on Atlassian under my account, creating some environments and installing some dependencies. Okay, it says your app is ready to work on, deploy, and install. Change to the directory Hello World to see your files. So let's just take a look inside there. I'm typing in ls. If you're on Windows, you type in dir, and you'll see a few files here. What I'm going to do is open this up in my editor, which is right here, and we can kind of take a look at what was created for us when we used Forge create. So first we have that manifest, the blueprint for our app. Let's take a look inside this manifest. Again, it's just a YAML file, describes the modules that we're using and the functions that are going to run related to this module. So here we have the Jira issue panel module, the title of our app or the app name. If we go into the source folder here, we have a couple folders, front end and resolvers. And front end is exactly what it sounds like. This is what's rendered in the client's browser. And let's just get down to the meat of the app, which is right here. It returns some text fragments, hello world, and then some other things that are happening here. And then there's this resolvers folder, which is contains this index.js file, which is back-end functionality. Like we would do things here, like maybe make API calls, REST API calls to external APIs or product APIs, things that we would not call from the front end, but they can communicate with each other. So let's just try this out. Let's go our next command. Let me clear the screen here. Now that we're inside this directory, we're inside hello world. Let's do the forge deploy command. So the first command we did was forge create. Forge deploy. It's going to do some linting or some syntax checking on our code. Then it's going to package it all up and upload it into the Atlassian cloud. And at the stage, it's ready to be utilized and installed, but it's not quite installed on our test instance yet. Now it is deployed. It says deployed hello world to the development environment. There's one other command that we need to run, and that is forge install. This is the equivalent of, let's say, going to the marketplace and installing an app, but we're essentially sideloading this app. So let's go to Jira, type in the name of our instance. Mine looks like this. Here you would type in your developer instance URL. Installing your app onto development, install complete. Your app is in the development environment, is now installed on Jira here. Let's go over to my test instance and see what this thing does. So this is an issue panel module that we're using. Remember that in our manifest. So this is my first issue. We'll create an issue. Let's go inside of that issue, view. And if we click on apps, and you'll find our hello world is right there, it opened up this new issue panel right here. And lo and behold, it's printing, as the front-end JSX code shows, it's printing hello world. It's printing it twice because what's actually happening here is that first hello world, let me adjust my windows here. The first hello world on our issue panel comes from this text fragment, and that second one here is coming from the back end. And this essentially demonstrates what it's like, how we're making a call to a back-end function. We have this back-end function here called getText, and it's just returning hello world. Let's just make it say something else. Hello from the back-end resolver code. I'm going to save that, and let's redeploy it. Okay, the changes have been deployed, and if I were to reload this issue, there's our hello world app, and the first part says hello world, and that second hello world was replaced with a new string, hello from the backend resolver code. Look at that. In just a few minutes, we were able to forge create, forge deploy, and forge install, and there you have it, your very first Forge app running inside Jira. To the first-time Forge app developers, congratulations. You've created, deployed, and installed your first Forge app from scratch. In the next section, we'll go a bit deeper and learn how we can add a bit more muscle to our apps. We're going to add some actions and new behaviors by using product events and product APIs. First, let's explore product events. These are events that are fired when a user interacts with Jira. For example, let's say we wanted to create an automation that listens for newly created issues or perform some action when a new comment is added to an issue. These are what we call product events. Let's take a closer look. Here's a representation of how product events work. Let's say I'm a Jira user and I just created a ticket. Just moments after that ticket's made, Jira fires off an issue created event which contains details about the new issue. If our Forge app is subscribed to this event, the app will receive the event with its respective payload containing all the details about this new issue. Once the Forge app receives the event, it can do whatever actions that we define in our code. For example, maybe an action is to call the Jira REST API to write a comment or update a custom field value. Depending on the use case that you're solving with your app, you can use any of the hundreds of Jira product APIs available. And in addition to the issue created event, there are about 40 other Jira events available that your Forge app can subscribe to. So as you can imagine, a common use case for using product events is for building automations with Forge, wherein the events act as the trigger to initiate certain automation rules or tasks that you build into your Forge app. Now, let's apply some of what we just learned. In our next exercise, we want to subscribe to the issue created event. Lucky for us, we can use one of Forge CLI's available templates to do this very quickly and easily. Let's all open up our terminals together and hop over to the development screen. We're going to do something very similar to what we did with Hello World. We're going to use Forge Create. And after entering in the app name, we're just going to select the category Show All. And for template, you're going to scroll around for product trigger. Let me hop over to my terminal now, and we can do this exercise together. Okay, I have my terminal right down here, and I'm in the folder where we had our last exercise. Let's use the command forge create to create our second app. We'll call this product trigger. And we will select show all. And instead of scrolling all the way down, I'm going to hit the up arrow a couple times and look for product trigger. There it is. Now it's going to create the app locally from a template and register it. And there we go. If you look at the directory, there should be a new folder, product trigger. Let's go inside that directory and we take a look and see what's inside. We have a manifest. And so I'm going to open this up in Visual Studio, my editor. Let's take a look at that manifest and see how it's different from our old one. In our last exercise, we had the Jira issue panel module. Here we have a new module called trigger. And for the trigger module, there's an events value here. And this is the event that our Forge app is subscribing to, which is the Jira created issue event. And when that event is fired and our app receives the event, it'll execute some code. So let's take a look and see what code it runs. We'll open up the source folder here. Notice there's only one index file instead of the front end and back end. It's just a simple single source file. And lo and behold, it's doing a console log hello world. So if we were to install this, it's not really going to do anything. All it's going to do is console log back into our terminal hello world. Why don't we add a little bit of something in here? Let's just console log something other than hello world. We'll comment that line out, and we want to see what does that event data look like. So you'll notice that there is this event value that's being passed to our run function. Let's just console log that and see what happens. I'm going to save that. So the next command, can you guess? We did a forge create. The next one would be forge deploy. Can't install it yet. You have to deploy it first. But we have an error. And what is the error? Let's stretch this out a bit. It says, trigger event AVI Jira created issue requires a read Jira work scope. Let's read about that in the documentation. I'm going to head over to developer.atlassian.com. And let's just maybe search for that. AVI, Jira. Look at that, Jira created Jira events. So I'm in the documentation. If you want to get there manually, you just go to reference, events, and then product events, Jira. And what I'm doing, I just want to see, since we're utilizing this event, what does it require? Here it is. So, Jira created issue event. An event with the name AVI Jira created issue is sent when an issue is created. The OAuth scope is read Jira work. So this is what it needs. And that definitely corroborates what the error message we got here. So we can go into our manifest and put in the permissions and the scopes in our manifest. However, if we don't know what the syntax is like for that manifest, we can just run this command, forge lint fix. And there it is. It inserted these three lines, permissions, scopes, and read Jira work. So now when we try to deploy, let's see if we still get that error. No issues found. So now what it's doing is what I thought it would be doing the first time. It's packaging up our app, uploading it into the Atlassian cloud, and it will be ready for installation next once this is deployed into the development environment. Excellent. Deployed product trigger, that's the name of our app, to the development environment. Now we can move to the next command, which is Forge install. And I'm going to put this on my dev instance. So choose Jira, type in your instance name. Again, just to be clear, this is my development and testing instance. You'll have to type in the URL of yours. Here's something different. Last time we installed Hello World, it didn't provide any information like this because there were no scopes. There were no permissions in our manifest. But this time it's asking us, hey, are you sure you want to continue? It has these scopes. Your app in the development environment is now installed on Jira. Okay. So it tells us that this app is now installed on my testing instance. What do we want to do? It is deployed, it's installed. We're going to use a new Forge command called Forge Tunnel. And it's a special command that allows you to quickly debug and iterate code that you might be writing, like what we're doing right now. And every invocation that occurs, or every time the app is run, instead of using the version that we just deployed to the Atlassian cloud, it's going to intercept that request and send it back to my local machine that has the tunnel running. And it doesn't do this for every user of the app. It only intercepts requests for which the user that I'm logged into here on my instance and the user that I'm logged into in the Forge CLI. So let's try this out. If I were to create a new issue, what we expect to happen is our Forge app should receive an event. And when it receives that issue created event, it should execute this code. And before the code just said hello world, now we're going to, in fact, why don't we just do that? Why don't we just comment out this console log event? Let's put it back to the original state where it just says hello world. I'm going to save this. Control S. And notice that when I save it, the tunnel refreshed. Watch, we'll do this again. File, save, and take a look at what happens. It rebundles the code locally, and then it checks everything, and now it's listening for requests. So let's create a new issue and see what happens. Product trigger test issue number 1. And create. And just like that, what had happened is we created a new issue. Because this Forge app is installed on this instance and the Forge app is subscribed to the create issue event, it then ran the code located here in index.jsx, and all it did was print hello world. So let's go back. Let's comment out the hello world, and I'm going to bring back console log event. Watch what happens when I hit save. Again, this is the Forge tunnel. And now it's listening for requests again. So let's create a new issue. Another one. My second product trigger test issue. Number 2. Create. Here we go. Very different, isn't it? So now, instead of just printing or console logging hello world, we're console logging in the event data. And like I said earlier, whenever that event is fired and our Forge app receives that event data, it receives everything about the issue that was just created. Here's the issue ID, here's the issue key, the summary, etc. To start a tunnel, it's as simple as this command, Forge tunnel. And if you read it, tunnel redirects requests you make to your local machine. It's a really useful tool. So here's the thing. Because I did not deploy the latest changes here, this console log event, if I were to create an issue now, of course, we would not see it pop in our terminal here. There is a developer console on developer.atlassian.com where you can view logs. in those logs, you would not see the event data at this time. You'd only see the words hello world because we have not deployed. So let's just deploy this. Forge deploy. And what we're doing is, we're deploying the latest changes here, this console log event. When we were running the tunnel, it was running the code locally that I have locally on my machine, not the code that was deployed. So we want to deploy this. Okay, now it's deployed. Now let's talk about REST APIs. In a nutshell, APIs are used to access resources or call services. In the context of Jira APIs, we have issues and projects as resources. Should we want to get the details of an issue, like a summary or a description, we can use an API method to access the resource and get the desired information. But APIs also allow us to create and update resources, which means we can do things like update issues and add comments. So where does Forge come in? Forge makes it easy for us to call product REST APIs, and today we're going to try that out. Here's how it works. For example, from the app, let's say we want to get the issue details from Jira. The app calls the REST API to request the information, and when Jira receives the request, like a well-formed request, it'll respond with the information being requested, and that's a simplified view of how it actually works. So for this next exercise, let's enhance the product trigger app that we just built by having it perform some kind of action. Once our app receives the issue created event, we'll have it add a comment to the newly created issue. And to do this, we need to utilize the Jira REST APIs. Before we start coding, let's use comments to write the requirements first, in order to have a clearer picture of what we want to do. So for the first requirement, we need to add the necessary import statements to call a REST API. And this import will allow us to use functions defined in external libraries. And from experience, I know that if I want to use methods or classes from libraries external to my code, I need to import them first so I can use them. So at the very top of your index.jsx, just add a comment like this: to do, add necessary imports to call a REST API. For the next requirement, we need to call the Jira REST API that's going to add a comment to the issue. So let's not worry about what API method that is right now. For now, let's just keep writing our requirements. So here, to do, call the Jira REST API to add a comment to the issue. And so the front end, I think that's all we need to do right now. So heading over to the manifest. Based on the previous scope error that we received when we tried to deploy the product trigger app, we saw that certain extension points that access resources require certain scopes. Since adding a comment to an issue is technically accessing the issue comment resource, we need to add the correct scope so that our app can make that API call. That said, we're going to add this to do comment right here at the bottom of our manifest in that scopes. To do, add the REST API scope. All right, that looks good. All right, next, I'd like you to open up your browser and go to the URL developer.atlassian.com. And this is a site where you're going to find all of Atlassian's developer documentation. And in today's session, you're also going to learn how to navigate through the developer docs. So at the very top right, you'll find the search bar, and let's search for add comment. And this will take us to the add comment REST API method. What I'd like you to do, though, it defaults to the v3 beta API. Let's go over to v2 on the top left. Select that. And we're going to find the issue comments resource on the left-hand side and find the add comment method. So now we've seen the docs and we know what REST API we need. Let's go and address some of these requirements on the left-hand side in our code. So the first requirement we had was add the necessary imports to call the REST API. You'll see on the right-hand side we have some code snippets, and this makes it really easy for us to do some copying and pasting. So this looks like the line we're going to need to fulfill our first requirement. Let's highlight that and copy, and we'll paste it right below. All right, looking good. And for the second requirement, which is down here, call the Jira REST API to add a comment. Again, let's just take a look at the sample code, and See, it's defining a body, and it's using the REST API here and console logging. Let's copy and paste that completely over to our code right below our requirement. All right. Are you done with copying and pasting? Again, the importing the library, and then the sample code to make an API call to add a comment. All right, great. So one of the really lovely things about Forge is that it makes it very easy to make REST API calls. You don't have to worry about things like authentication, API tokens, keys, or secrets. That package that we imported right here, it has a convenience method that makes it very easy to make an API call, and it manages the authentication for us. However, one thing you need to be aware of is that you can make an API call in Forge as the user or as an app. So in this code snippet, it defaulted to as user. However, in this product trigger app that we're working on, it's only invoked or run when it is triggered by a product event. So therefore, it doesn't have a specific user context, right? Because it's not being run because of direct user interaction with our app. That being said, we have to change this from as user to as app. And maybe this is a good time to kind of dive into the differences between as app and as user. So you would use as app if you want to invoke the REST API as the app. And in certain scenarios, like the example that we have, where the user context isn't available, we'd want to use as app. That's the way to go. Using as app makes a lot of authenticated calls easier. However, you have to be cautious, as any user can trigger a successful API call since the app action is authenticated as the app. On the other hand, as user invokes a REST API as a user who is interacting with the app. This means that the REST API call will only be successful if the user has necessary permissions to the resource. So let's say you have REST API call in your Forge code to create an issue. And by acting as a user, let's say they're interacting with your app within the Jira UI in real time. We have a user, let's call her Beyonce. If Beyonce does not have create issue permissions, then that REST API call will fail. In the same scenario, if we use as app and the app has create issue permissions, then Beyonce will be able to create issues by proxying as the app, which I think is something that we don't want to do most of the time. So when choosing between the two, you just want to be mindful about what you're trying to achieve. Okay, let's get back to our code. So we change this to as app. And if you look at this API call that we're making here, the code that we copied over from the docs, the API method requires an issue ID or a key. So let's create a variable for that. Var issue ID or key. And we'll just keep it blank for now. Where do we get this from? We got to figure out how we're going to grab that issue key or ID. Additionally, this is just a placeholder. We need to turn this into a variable. So we're going to put a $sign here. It'll be replaced with the value that we defined here. So when we console logged out the event data in the last exercise, we saw that the issue is returned. And so we can actually grab that issue key or issue ID right here. So we could just say it is event.issue.id. Again, that's right here. Okay. Additionally, the code snippet that was provided for us has extra object here that I'd like to remove. I'm just going to remove this visibility. And you'll need to do that too. So let's just delete that and delete this extra comma at the end. And so now the body is the body data. It just contains this body string inside this JSON object. So latest changes were we changed this from as user to as app. We found the issue ID or key by traversing through the event data that was returned to us. We added a $sign here to reference that variable inside this request. And Let's save that. And we have one more to do. And we need to find the REST API scope that's required in order for us to make this API call, which is adding a comment. So let's go back to our manifest and find out what we need to put in here. So if we look at the documentation, add comment, the scope that's required is write Jira work. So let's just add that right here. Write Jira work. Okay, so I'll save that and let's try Forge deploy. We need to do a deploy because we made a change to the manifest. Plus we made some significant code changes in here. So let's see if there's any errors found, which there have not been any errors, but that's good. All right, now it's deployed and we got this message saying, we've detected new scopes, run Forge install upgrade. Because we have already installed this, so we need to run this install upgrade because the scopes need to be approved. Your app will be upgraded with the following additional scopes. Write Jira work. Fantastic. Now I'm going to run the tunnel so we can see what's happening. And we'll give it a try. Okay, it's listening for requests. Let's try to add a new issue. And how about that? What do we get? We received a couple console logs. Here's one, here's another, and 201 created. So let's go to that new issue and see if there is a comment. And there it is. Look at that. It was made by the Product Trigger app, and it says our lorem ipsum string that we have up here. Fantastic. Now, wasn't that a lot of fun? And on top of that, it was fairly easy to do. Let's take a quick breather and reflect on what we've learned so far. We kicked things off by building a Hello World app where we use the Jira issue panel. Then we learned about product events and built an app that uses one, subscribing to the Jira created issue event. Then we learned about making REST API calls from Forge, and we were able to use the add comment API in our app. And that took about maybe a dozen lines of code or less. And finally, remember, the docs are your friend. I hope that you're feeling more comfortable navigating the docs and using them as a resource to help you build your own apps and integrations as you move forward. Next up, we'll be working with the UI. So far, we work mostly on things happening behind the scenes, like product events and calling REST APIs. We briefly touched on the UI for the Hello World app, our first exercise, but we haven't really added much functionality to the user interface. In this section, we'll start to poke around with some basic UI elements to enhance Jira UIs with Forge. Before we start writing code, let's revisit something I talked about earlier and discuss the options you have for building out a UI for a Forge app. Again, you have two options, UIKit and custom UI. With UIKit, it's relatively easier to get started, and you can take advantage of the built-in UIKit components. These components are rendered natively, which gives off a more familiar experience, design, and look and feel of the Jira product experience. With custom UI, the app runs in an iframe that provides an isolated environment for the app's UI to be rendered. With custom UI, you can define your app static resources like CSS, HTML, JS, and images. If you prefer more flexibility on your app's UI, then going the custom UI route might be something that you'll want to dive into. For this next exercise, we'll add some formatting to the text component and add some different components in the issue panel from our Hello World app. Discovering and trying out different UIKit components can be a lot of fun. You'll discover there's a wide range of pre-built, customizable components at your disposal. By combining them, you can build truly rich app experiences that deliver both great usability and delight to your users. In addition to being easy to use and customizable, UIKit components are built to align with the Atlassian design system and visual language used across Atlassian products. That helps you build UIs that are polished and seamless with little effort. In our Hello World app, you'll see that we're using the text component, which is what we use to display the Hello World string. When you take a closer look in the documentation for this component, you'll find that it also has inline children components like EM and strong, allowing you to make inline text appear in italics or bold. To familiarize ourselves with the text formats, let's try them out by updating our index.jsx file in the front end of our Hello World app. First, we're going to add the necessary imports, EM for emphasis and strong to make text bold. Once imported, let's update the content of the text component by adding the open and closing strong tags and EM tags inside the text. Okay, let's do that together. I'm going to hop over to my editor. I have my terminal here in the bottom left and my test instance here on the right. And I'm in the folder that has both my Hello World and product trigger. You can go into Hello World. See that? I'm going to open it up here in my editor. And I'm going to go to the source, front end, index.jsx. This is the file we're going to update. And again, what we're going to do is add the EM, the emphasis, and strong to our imports. So, comma, EM, and strong. All right, so these imported those components. And we're going to make some changes to the text here. Let's make Hello World bold with strong. And we can remove that backend component and let's just do EM and Hello World in italics. So again, what we added were the imports EM and strong, and we added the strong tags around Hello World, and we added another text tag, and inside the emphasis tags I put and Hello World in italics. And we'll save that. And let's run the tunnel. Okay, the tunnel is established. It's listening for requests. Let's reload one of our issue views. And there we have it. If you don't see your app, just click on Apps and then Hello World. Sometimes it might appear like this where the app isn't showing up. It's okay. Just hit Apps, Hello World, and it should persist for this issue going forward. So there we have it's in bold and now it's in italics. Pretty simple. Now that we've learned more about formatting the text component, let's try adding a new one, the lozenge. A lozenge is typically used to present item status in those little colored capsules like success or removed. Let's try it. First, we'll start with the import, adding lozenge to our import statement. And after importing it under your text component, we're going to add a lozenge component to the code. I'll hop over to my editor and we can do it together. So the first thing we're going to do is add lozenge to our imports. And the next thing we'll do is below all of this, we're going to add a new tag. Lozenge. This is a lozenge. Okay, save that. Our tunnel is reloading, and look at that. Automatically, it just came up. This is a lozenge right there. Lovely. Change the text again. Perfect. And while we're at it, let's try adding a basic button to our UI. Again, we start by adding button to the import statement. After importing it, under your previously created lozenge component, add the button. All right, I'm going to head back to my editor, and let's do this together. So again, back to the imports, type in the word button, and we'll add a button below our lozenge. We'll just have it say, click me. And I'll save that. And look at that, there's the click me button. Doesn't do a whole lot, but there it is. So each component has its own respective properties. Let's try updating some of the ones that we have here in our code. For the lozenge, we'll make some updates for the button, etc. And then we're also going to play around with some of the layouts. Right now, they're kind of just sitting next to each other. We're going to maybe stack them together, make it look a little cleaner. So heading over to the documentation for the lozenge component, these are the properties. You have appearance, children is bold, max width, and what we're interested in here is the appearance. Maybe let's add something like success. And how does that look? Lozenge default. Let's find another example. Here we go. Lozenge appearance equals success. Let's just copy that and paste it. All right, save it and see what happens. Look at that, it turned it green. Let's try another one out. Appearance value removed. Paste that in. I'm going to save that. How about that? So for the properties of each of these UIKit components, it's all in the documentation. You can just go down to the properties here and see what's available. And of course, there's lots of examples and example code provided to you as well, so you can see what all the other options are. And now we have this button that is just floating out here. It's beside the lozenge. Let's use one of the layouts called stack so we can stack them together. So let's learn about the stack. So the stack component. A stack manages the vertical layout of direct children using Flexbox. So I'm going to zoom out a little bit so we can see some of these examples. Okay, so what we have here is we just add stack and then we put some components inside the stack, and that should help us to align them vertically. Let's try it. So let's go to our code again, and we're going to add stack to our imports. And let's put the lozenge and the button inside of a stack. So here we go, stack. And I'm going to, that's a beginning stack, an ending tag for stack. We're going to put these inside. I'm going to cut this and paste them right here. And I'm going to highlight this text and hit tab, make it look a little cleaner. Okay, let's get our view again and see what changes here as I save this. Okay, interesting. It made my button absolutely enormous, and as well as it stretched it all the way across. Maybe what we need to do is add this property, align inline start. What does align inline mean? Used to align children along the cross axes. Let's try that. Align inline equals start. That's more like it. The lozenge is there, the button's there, maybe some space. Maybe we can add a little bit of space. How about this space 200? Let's save that. That's more like it. For our next exercise, we're going to build a basic issue validator. We'll modify our Hello World issue panel app that we made earlier, and we'll start to play around with some UIKit components and their properties. For this exercise, we're going to build the UI side for this issue validator. The issue validator app we're building can be used to check certain states and fields in your issue and then remind users to adhere to specific team standards. For example, let's say your team agreed that description fields should always contain a value, and here we can add a check for that. But in this section, instead of adding the logic to our code, we'll first focus on which UIKit components to use and their respective properties. Okay, let's get started here, back in the editor. So we're back at Hello World where we left off, and I think what I'd like to do first is let's just get rid of everything that's in here. The first thing we want to do is
render the lozenge and text components to mimic the design up at the top right. Okay, so here at the top right, this is what we want to create, is essentially this layout of a lozenge and some text, some lozenge and some text. So let's give that a try. Let's just add a lozenge. Appearance equals removed. We'll put the text no. And then we'll add a text component that says this issue has a valid assignee that is different from the reporter. Okay. And let's just see what that looks like. So let's save this. We'll rerun our tunnel. And we're going to look here on the right-hand side. All right. Tunnel says listening for requests. It is now established. Let's reload our issue view. And okay, we have our lozenge and we have our text. The thing is that we want them on the same line. And we used the stack component before, but there's another component we need to use, and it's called the inline component. And the inline component, is, as described, is an inline manages the horizontal layout of direct children using Flexbox. So we want to keep them both in the same line. So let's just try that. Let's just wrap these in an inline and see what happens. So I added this inline beginning and ending tag, and I put the lozenge and the text inside there. And I think we're missing one thing. We need to go to the very top and import inline. Okay, let's save. Head back to our issue view, and let's take a look and see. Ah, well, there you go. They are, it doesn't appear that they are, but they are definitely on the same line. Let's see what we can do to really get these things completely vertically aligned now. So we have some properties that we'll want to investigate, and align block used to align children along the main axis. Okay, let's try align block is equal to baseline. And what I believe this will do, it should put them, yes, that's exactly what we're looking for. Just like that. Okay, so let's create the second line here. So we need another lozenge. Why don't we just copy and paste this completely, and instead of lozenge appearance equals removed, we'll go with success. We'll change this to, let's capitalize this. We'll change this to yes, and we'll change this text value, the string, to say the issue has description. Okay, so what I did is I copied this, pasted it below, just changed the appearance in the lozenge to be success. Again, we're just trying to mimic this for now, and then we'll maybe add a little bit of logic later. So we have another inline and with a lozenge and text, and let's save this and see what happens right here. Oh, okay, not looking bad. One thing that we probably want to do, though, is wrap this thing into a stack, because a stack, if you remember, stack manages the vertical layout of direct children. So this is the vertical layout. So we'll just wrap all of this inside of a stack. And we'll tab this over and save. I'm guessing it's going to look pretty much the same. Okay, not bad. One thing that I did notice that we have a little more spacing in here, so let's think about where we need to put that spacing. Let's go back to inline, and we'll go scroll down and look at the examples. I think that this is a space property we want to use, but Let's take a look here. Yeah, indeed. So inline space dot 200. Maybe we'll go with something a little smaller. Say space equals space dot 100. We'll try that here as well as on the other inline. So before I save this, I wrap these in a stack so that this inline component with the two other components, lozenge and text, as well as this inline component with lozenge and text, these two inlines, this one and this one, are going to be part of this stack. So let's save this now and take a look and see how this looks. Do we have more space? We do. This pretty much looks just like what we have up here. Good job. So the next thing I'd like to do is address the fact that these statuses, this no and this yes, this success, this removed, these are statically placed into our rendered output. And the next thing I'd like to do is just add some code so that it's easy to flip back and forth between the two states in our UI. So instead of these static messages like no and yes and appearance properties, removed and success being hard-coded, we're going to add a little bit of UI logic using variables to flip those states. So let's add a to-do. Make lozenge text yes and no, and appearance property success removed non-static. Okay, so let's first create a variable to kind of track those states. So let's create a variable has valid assignee. And what we're going to do is just mimic what we have up here. Right now it says no, so we're just going to force it into false. But what we want to do is, based on this value, true or false, we want to affect what goes into this appearance property and then what goes into this lozenge text. So we'll need to create valid assignee appearance, and we're going to evaluate with this ternary operator has valid assignee. And how this works is that if it's true, we want the value to be success. If it's false, it'll be removed. So again, what this does is we're declaring a new variable called valid assignee appearance that we're eventually going to replace that with this. The value that it gets assigned depends on this evaluation. So this operator here will evaluate has valid assignee, and if it is true, then it'll take this string and store it in this variable. If this evaluates to false, then removed will be put there. Okay, do you see where we're going with this? So next, valid assignee lozenge text. We'll do the same evaluation on this, but instead of success removed, it's yes or no. So this is the text that we're talking about right here. Let's just try it. Let's just change it so that it is not going to have this static no. So let's replace that no with this variable here. And how you do that in JSX is curly brace and then the variable. And for the appearance, which is right here, we would put that in here. And I'll paste it. Wrap some curly braces. Notice though that you'll need to remove these quotes in order for this variable to be placed into this template. So what did we do? We created this variable called has valid assignee, and we just assigned it to false now. And then what we're going to do is we're going to test this and flip it to true and see whether the changes occur that we want. And the big thing that we did is this appearance is no longer going to be statically set with success or removed. We're going to use a variable. And then the same thing with this text of yes and no. It's going to be based on this variable. All right, so let's just save this and see if it looks the same. Okay, well, it did run. I'm just going to reload this to be certain. Okay, looks the same. If I ever flip this to true, what do you think is going to happen? If it's true, the valid assignee appearance should be changed to success, which is right here, and the lozenge text should be changed to yes. So these things should flip. Let's try it. Here we go. We're looking right here. Ha, lovely. Perfect. So we are halfway through. Let's just copy all of this and paste it. Instead of has valid assignee, we'll say has description, because that's what we're testing for here. We'll call this description appearance. And this is not, we don't want it checking the valid assignee. We want to check it whether it has description. Same thing here. And then description, lozenge text. Okay, so we have has description, true or false, and description appearance and description lozenge text. We need to add these into our rendered output here. So this needs to be replaced with this. Curly brace. We'll remove these quotes. And then this yes needs to be replaced with this variable here. Lovely. So true and true. Let's just flip this to false. And what I expect to happen is that this should say no in red. Absolutely wonderful. Okay, we are off to the races, and we have just addressed this to-do requirement. Let's stop the tunnel with Control-C, and then use Forge Deploy to upload our code to the cloud. And we're actually going to leave it there for now, since this exercise was focused on UI components. For extra credit homework after the workshop, try and finish the app, where you'll use the API to fetch the issue details and check whether or not the reporter and assignee are the same person, and whether or not the issue has a description. Now that we're becoming more familiar with built-in UIKit components, let's try something interesting. In this exercise, we'll be using the image UIKit component, which, as you would expect, renders an image in our UI. However, we're going to add a little bit of a twist. We're going to access an image resource that lives outside of our project. This means we'll access an image hosted somewhere else. And you can do this with Forge with a feature called external permissions. Let's just use the same app we've been working on, and we'll go through the steps to make this work. The external permissions section in the manifest is the place to declare the external resources or services that you want your Forge app to access. If these external resources are not declared, your Forge app will not be permitted to load them. In this exercise, we'll use external permissions to load an image that's hosted outside of our app, somewhere out on the internet. So let's take a closer look at how this works. First, we declare the source URL or host name of where the resource is located, and we make this declaration in the manifest. In doing so, we're allowing our app to access a resource hosted outside of our app. In this UI exercise, our app will reference an image from an external location. And if declared properly in the manifest, we'll be able to see that image load. Let's see how we'll approach this. First, we need to add the necessary import for the component to be used. So we're going to add image right there. And after updating the import statement, we're going to add an image component below the lozenges and text components at the bottom of our JSX output. The URL of the image we're going to load is go.atlassian.com/curious-cat. Okay, let's hop into our editors and make the changes to our code. So back to the editor, the first thing we want to do is add the necessary import. But maybe before we do that, let's do some cleanup here. I'm going to get rid of some of these components that we imported from earlier exercises that we're not using any longer. So this EM and strong, we can get rid of those. And even the button, we're not using that either. Okay, after inline, just comma, and type in the word image. And this is going to load the image component. On the right-hand side, it doesn't actually have the image UIKit component documentation. Okay, so now that we have that in place, the next step is to add the image to our JSX rendered output. So let's add the image tag here. So it's image, property would be right here, source equals, I said go.atlassian.com/curious-cat. Okay, I think that's it. We added the import image. We're using the image here. Let's save this and let's run the tunnel. Ooh, okay. We got a couple of errors here. The domain go.atlassian.com is not included in the permissions section. Egress required. Curious cat is not included. Okay, so we have two errors, and they're saying that if we want to fix this, we just have to run forge lint fix. And what they're saying is that we just don't have the permissions defined in our manifest. So let's hit Control-C to stop our tunnel. And then we're going to run this command, forge lint fix. And let's see what happens. Well, look at that. Magic. It added a new permission section, no scopes, but this is the part that we're really interested in. External images, go.atlassian.com. So this is what's required in order for us to have our Forge app be able to load images from an external URL. So how about now? Should we try Forge tunnel again? I think so. Okay, we have another error, but this time it's not in our terminal from our tunnel. We're seeing it in the UI. And it says egress permissions are missing in the manifest. Well, we have them in the manifest. What do you suppose the problem is? Well, I think the problem is that we've only made these changes locally. We haven't deployed them yet. So that's our next command we need to run. We need to run forge deploy. And again, you make any material changes to the manifest, especially around permissions, you're going to need to redeploy. Okay, it's deployed, and we have another warning message here. We've detected new scopes. You need to run forge install upgrade. Okay, let's follow the directions. I'm going to paste this, forge install upgrade, and I'll remind you what this means. This means that our installation that is currently on our testing instance is out of date and it needs to be updated. So we're just going to run that, hit yes. This is also related to the fact that we made changes to the manifest. We can make changes to JavaScript code in this index.jsx and not have to redeploy, not have to do a reinstall or a forced upgrade. But you make changes to the manifest, you're going to need to do a redeploy and a forge install upgrade. Okay, now it's saying that it's complete. Now, finally, let's try the tunnel and see if we can get some traction here. Okay, it is ready for requests. We'll reload. Hey, beautiful. And that's the image loaded successfully. So just to recap, what did we do? We added the import for the image component, and then we added the image tag here in our JSX output. And then lastly, which perhaps should have been firstly, was the manifest. We needed to add the correct external permissions to load this image properly. And maybe just for fun, let's take a look at the image component documentation and see what properties are available to us. We've already used one. We used the source property, the remote URL of the image. Let's try out size. We'll try X small, and let's save that. Head back here, see what happens. Ooh, look at that. Even cuter. You know what would be even cuter than that? A second cat. Let's copy this and paste, and we'll add a -2. If I'm not mistaken, there should be a second cat waiting for us. Save. Hey, there they go. How about we put them side by side? We'll use the inline component. Inline, we'll do a line block equals baseline, just like there. Space equals space.100. And let's slap these two images inside this inline block, and we'll save it. Haha, beautiful. Way to go. Do you see how easy this is and how much fun this can be? When building a Forge app, there might be times where, depending on certain conditions, you might want to show or hide a UI module. For example, in Jira, you might only want to display a set of information depending on the issue type, or even depending on the role or permissions of the user. In this section and exercise, we're going to learn about something called display conditions. So depending on your app's use case and scenarios, you might want to hide modules from rendering in your app. And with display conditions, you can do that. For the Jira issue panel and other issue view related modules, here are some of the properties that can be evaluated when using display conditions. You can use different issue and project properties like key, ID, and type as conditions that can be checked. And you can also determine whether a module will be visible depending on the user's current permissions, like if they can add comments, if they can assign issues, or if they even have Jira admin privileges. To test it out, let's use the issue type as the condition. In our manifest, we're going to add the display condition that checks if the issue type is a bug. This means that the issue panel will only be visible if the issue type is a bug. Okay, let's head over to our editors and let's try it right now. Okay, so the first thing you want to do is actually, I created a new project, like an IT service project, to make sure that there was a bug type, issue type. And let's just make sure that this is not a bug. Let's turn it into a new feature. So I just went to the move function in the issue view, hit next. And what I'm doing is I'm converting this from a bug to a new feature so that we can see it work. Okay, so it's a new feature instead of a bug, and you'll notice that the hello world here is still, our app is still running. So let's go and add the display condition. And where we need to put it is not here. We need to put it at the level of this Jira issue panel module. So I'm going to hit enter here, type in display conditions, issue type bug, and let's save that. And because we're making a change to the manifest, we need to do a deploy. So when I deploy this, what I'm hoping will happen is that this app will no longer be visible. Okay, it's deployed. So again, before we hit reload here on the issue, what we did is we added a display condition that makes it a requirement that in order for this to be visible, this issue panel, this must be true. The issue type must be bug. What we did is we modified the issue type to be a new feature and not a bug. So when I hit reload, what do you think is going to happen? Fantastic. It did not show up, just like we planned. Now let's convert this into a bug again and see if our app becomes visible. Okay, we're changing it from new feature to bug, and there it is. Hello world shows up again. Again, because of this display condition. Awesome. So let's get on to a use case. In this use case, we have Jane, a Scrum Master, and she wants a new custom field that only accepts whole numbers and does not have separators like commas or periods. The use case is an actual open feature request for both Jira Data Center and Jira Cloud. In fact, this feature request has been around for quite a while. The Data Center feature request has about 400 people that have upvoted for it, and on the cloud side, it's garnered just about 200 plus votes. When we look at the existing number custom field type, this is how it appears. The Jira admin, she added this custom field titled year, but it doesn't look so hot with a comma showing up. To this, my colleague and fellow developer advocate Ian said, we can do this with Forge. Analyzing Jane's feature request and thinking about the requirements, we know that we need to create a new custom field type, and the field must only accept and display whole numbers or integers. Also, we need to make sure we get rid of those comma separators. So let's head back over to our terminal or console, and we're going to create a new Forge app. And we'll use the command forge create. For the name of our app, let's just call it integer CFT for custom field type. Select UIKit, Jira, and then Jira custom field type. Okay, go inside that folder, and I'll open it in our editor, and let's take a look at the manifest. Okay, so the module that we have for our app is a Jira custom field type. The name of our app, integer CFT, and this will be the name of the custom field type when we add it to our project in a moment. The big thing that we want to look at is this section called validation, and in it is an expression that performs a validation on the field. When someone tries to change a value, it's going to use this expression to validate whether it's a good value or not. And so what this expression means is that it's either going to be blank, value is null, or it has to match this expression. And the default expression, we haven't made any changes yet to meet our Scrum Master's requirements. The default expression that is in here is right here. This is a regular expression, and it's a pattern match, and it means that it can only contain the capital letters A through Z or lowercase a through Z. No numbers, no spaces. Maybe before we make any changes to this, let's just give it a try. So we're going to go with a Forge deploy. Followed by Forge install. And here you'll type in your dev instance name. All right. So let's add a custom field with this custom field type to our project. So go to your project, and on the left-hand side, find your project settings. Fields. Select edit fields here in the top right. And then custom fields here on the bottom left. And we're going to create a custom field. Now, it's asking us to select a field type, and these are the default field types. If you want to find ours, we'll go to Advanced, and you can either search for it or we'll just scroll and find it, and there it is, integer CFT. That's the new custom field type that we just added when we installed this new app. Select that, hit Next. We'll call this year, create. And now we have to apply this custom field to all these different screens. So select them all, click Update. Now if we go back to our project, we should see the field year right there with a little hello world message in there. So again, the expression for the default app is just A through Z and A through Z, upper or lowercase. Let's type in A, B, C, D, E, F, G and hit OK. And it saved it. Mind you, there is this little prepended hello in there that has something to do with our index.jsx file, which for our purposes, we really don't want to make any front-end modifications. But anyhow, back to the meat of this, which is in the manifest, is this regular expression. And so let's try something that would fail. This is a test. Now, why is it going to fail? I have some spaces here and I have a period. It does not match this expression. So let's see what happens. Well, it already says validation error, value is invalid. So we have to close, let's dismiss those or just save it with something like ABC. We'll hit OK and it saves it. All right, perfect. So that was the default configuration for our regular expression. If we want to only accept integers or numbers, we need to replace what's inside these square brackets with 0 through 9. And again, what this regular expression means is that from the beginning, that's what that caret is, and to the end, evaluating what's in the middle, it can only contain characters 0 through 9, and that plus sign means one or more characters. We've just changed it from A to Z to 0 through 9. And I'm going to save this and redeploy. And we'll also have to do a Forge install upgrade command. Okay, so now let's try typing in A, B, C, D, E, F, G. And it's saying that the value is invalid. But if we put a number in there, it will save it. So our regular expression change was applied. So now we can only type in numbers. How about if I tried a comma? Nope, won't work. It has to only be whole numbers. Okay, great. So what we want to do next is really disregard a lot of the UI-based parts of this app, because we're really just interested in having the number validation take place. So what we can do is just comment out these lines. As well as comment out the entire resources section. And effectively what this is doing is just skipping over all this front end code, because we're not interested in adding any additional prepending like the word hello in there. We just want to perform the validation at the time that a user tries to change that value. So I'm going to save this manifest. Do a Forge deploy. And then a Forge install upgrade again. And hopefully what we'll see when we reload this is the hello will disappear and it's just going to be the value. And in fact, there's another key difference. Instead of a pop-up showing here, we only have this error symbol here, tooltip, that's saying that the value is invalid. And I think that that's sufficient. Accepts numbers, will not accept anything else. That's perfect. I think that we met our requirements. So just to recap, created a new custom field type with Forge. That's why this module name is Jira Custom Field Type. And we accomplished what we wanted to accomplish, but just using a change, making a change to the manifest and modifying the regular expression to go from A to Z to just 0 through 9. And we don't need really any of these UI-based parts of our app. that was modifying how it was rendered. We were really just interested in the data validation at the time that a value was changed on the issue screen. Awesome. And that's a wrap. Let's recap on what we learned today. First, Forge makes it easy to build apps quickly. With the Forge create command, you're presented with nearly 100 app templates to help you get bootstrapped with sample code. Even for folks building their first Forge app, it can be done in less than 10 minutes. In fact, that last custom field app we just built probably could have been completed in less than 5. As for the user interface, you learned how easy it is to compose extensible UIs with UIKit. The UIKit components also have that native feel off the shelf. Having your Forge app make calls to the Jira REST API is simple with the use of convenience packages and methods. There's no need to deal with OAuth dances and storing API tokens. Just import the package and your app's ready to start making API calls. And lastly, if you need to reference or connect to external assets or services, Forge makes it easy to do that as well. You just need to provide the proper external permissions. In our exercise, we were loading an image from an external URL. But in addition to that, you can give your app permission to make REST API calls to external services as well. Well, that concludes this session on customizing Jira with Forge. There's a lot more exciting things to explore and learn about beyond what we covered today. Be sure to check out the sample apps, guides, and tutorials in the docs. I'll include links in the description. There's also a link to a repository that contains the exercises we did today, as well as some bonus exercises that we didn't cover in this video. To stay on top, subscribe to the Atlassian Developer YouTube channel and sign up for the newsletter. Thanks for watching.